I've got a wine cooler that's not working, and I'm down to this Embraco electromagnetic relay to test it to see if it works or doesn't work. The overload protector is this piece that goes on the compressor. It was bad, I've already replaced it, so taking that out of the equation. The rest of the schematic looks like this, courtesy of that website. You've got the line coming in, goes the overload protector right here, and then continues through, unless there's an overload obviously, to the motor, which then continues onto this relay, which is right here. And looking at a lot of websites, it talked about you should shake your relay, and if you hear a noise, then it's bad. Well, that's great if it's this kind of relay, but if it's electromagnetic like this, it better be moving or it's not going to work. So this is to help figure out whether, even though this one is still making noise, it still works or not. Here is the whole schematic that you can follow, and I'm going to visually show you in a second how it should look once it does function. I've already taken this apart to see what's inside, but to give you the example as well, you take those 4 prongs, pop them up, and there are some contacts in here that have been severely pitted and corroded. You can see there's one right there, and obviously the other side of it is on the other side of that silver thing. This part comes out, and then this here is your magnet. So when the electricity passes through, it draws the magnet in, which then draws these contacts up. There's 2 more contacts on the top of those, and that bridges the connection, and it does what it's supposed to do. Now, it's only a momentary connection because in the circuit, as I understand it, and I'm no electrician, you only need the start circuit momentarily, very briefly, and then it should drop out. So that's the whole function of this. It should connect and then drop out after it gets full connection. So these were completely corroded. I cleaned them up, got some very fine wet dry sandpaper, and then used some contact cleaner to clean them up, and have put them back. So now we're going to test it and see how it does function. Alright, so this is where we'll connect the neutral. Following on over to here, and I'll put this in first to show you. This is a handy-dandy way of just testing it using light bulbs as the visual. So there's 2 sides to the circuit here. You got the start circuit, which should obviously light up only momentarily when the call for the compressor is turned on, and then it should drop out. And then over here, you have the run circuit, which when the call for the compressor is turned on, it should always stay on. So just following the wiring, and I'll turn this on in a second and you'll see. So the hot goes to the separate loads, and then the neutral comes through here. And then this side is the start side, and this side is the run side. So this side should always be on when the call for the compressor is on, and this side should only come on and then drop out. So to visualize that, you have to have some kind of load on here. So I try to find something with a motor. I tried the fan by itself, and that didn't seem to work, as you'll see here. So when I turn this on, we get power here from the circuit side, fan's running, but we saw no lights over here on the start circuit, and I didn't hear anything moving on the electromagnetic side, and that's because the fan did not draw enough amperage. The paper shredder does a much better job, especially when it has paper in it, for creating a load. So when you turn that on, it's got in there, it'll definitely have a lot more draw, and you'll watch these lights. So you might be able to hear the click of the relay, plus the lights will flash. So you can see them just briefly turn on and off, which means this is doing what it's supposed to. It's drawing it up, connecting, and then dropping out, and then meanwhile this guy stays on. So this guy is functioning just fine. It's not my problem. The problem I've got left is the compressor motor.